Most importantly, or most fundamentally, entropy increases over time. Entropy is the way that we have of talking about the disorderliness, the randomness, the disorganization of stuff over time. And there's a general principle that organized things like unbroken eggs can easily evolve into disorganized things like broken eggs, but never backward the other way, or at least very, very rarely, or at least you need to do a lot of work to make it happen. If you live in a room or you have an office and it's clean, it will naturally happen that it becomes messy over time. If your office or room is messy, it will never clean itself up all by itself. You need to do work. That's because entropy is increasing. If you like to think of it as the working out of a great law of physics, be my guest. And the reason why this is true is because there are more ways to be high entropy than to be low entropy. There are more arrangements of stuff that are messy than are organized. This was the brilliant insight of Ludwig Boltzmann, the 19th century physicist. And so therefore, if you start in a configuration of low entropy, entropy naturally increases. The problem was, therefore, why isn't entropy at its maximum value? There are many, many more ways for entropy to be high than for entropy to be low. Why is it true that entropy was ever low? So Boltzmann, in other words, explains why, given the entropy of the universe today, it will be higher tomorrow. There are more ways to be high entropy than to be low entropy, but he does not explain why it was lower yesterday. I'm here to tell you the answer. The reason the entropy of the universe was lower yesterday than today is because it was even lower the day before yesterday. And I know the reason why that's true too, because it was even lower the day before that. And this reasoning goes back 13.7 billion years to the Big Bang. The reason why the universe has had a low entropy all along is because it started that way. Nobody knows why. This is a profound question for modern cosmology. But once you give me that, I can explain all of the differences between the past and the future. So one way of thinking about it is, we all agree that there's no arrow of space, right? If you're out there in a spacesuit, there'd be no difference between up and down, left, right, forward, backward. But here in this room there is. If I drop the laser pointer, I know it's going to go down. There's an arrow of space pointing down. Nobody thinks that this is some profound consequence of the fundamental laws of physics. It's because we live in the vicinity of a very influential object, namely the Earth. The point of this discussion is that time is like that. There is no intrinsic arrow of time in the laws of physics, but we think that there is in our observable universe because we live in the aftermath of a very influential event, the Big Bang. I'm not going to explain why the Big Bang was low entropy, because nobody knows. Don't believe anyone who comes in here and tells you they know.